Hello students, this is our second unit, Electrostatic Potential and Capacitance. Our first unit has been completed, electric charges and field. Let's start second unit. The very first term we have to know the electrostatic potential energy. This unit is also known as the application of electric field. So let's start with this term electrostatic potential energy. Suppose this is a positive charge configuration. Okay, it means this positive charge configuration will produce an electric field around it. This is a positive charge configuration and this positive charge configuration will produce an electric field around it. ये अपने चारों ओर एक इलेक्ट्रिक फील्ड को क्या करेगी, प्रोड्यूस करेगी. एंड सपोज देयर इज अ पॉइंट चार्ज Q at a point P at a certain distance from this charge configuration. इस कॉन्फ़िगरेशन से पॉइंट P पर एक पॉइंट चार्ज Q रखा हुआ है. सो व्हाट विल हैपन, क्या होगा, दिस टेस्ट चार्ज इज आल्सो पॉजिटिव, दिस इलेक्ट्रिक फील्ड is produced by the positive charge. It means this charge configuration will repel this charge with a force, means with the electrostatic force FEL. It means what will happen if I left this charge free? It will start moving away from this configuration. Means जब हम इस चार्ज को फ्री छोड़ देंगे तो क्या होगा, ये इस चार्ज से दूर जाने लगेगा. It means it will start moving away from this charge configuration, and this moving charge indicates that it will start getting some kinetic energy. Means इसमें क्या आ जाएगी, कुछ ना कुछ kinetic energy आ जाएगी. But according to energy conservation, energy can never be produced. Energy को कभी create नहीं किया जा सकता. It means when this charge was at rest at point P, it must have some stored energy. जब ये point charge आपका रेस्ट में था पॉइंट P पर, इट मीन्स इसमें कुछ ना कुछ एनर्जी स्टोर्ड होगी जो आगे चलकर किस में कन्वर्ट हुई, काइनेटिक एनर्जी में. सो दिस स्टोर्ड एनर्जी इज नोन एज पोटेंशियल एनर्जी. ओके, लेट्स रिपीट इट. सपोज आई एम हैविंग ए पॉजिटिव चार्ज कॉन्फ़िगरेशन. इट मीन्स देयर इज ए इलेक्ट्रिक फील्ड अराउंड इट due to this charge configuration, and there is a point charge Q at a certain point P from this charge configuration. Then this charge configuration will repel this charge with a force F electrostatic. ये इस चार्ज Q को एक फोर्स, इलेक्ट्रोस्टैटिक फोर्स से क्या करने लगेगा, रिपेल करने लगेगा. मीन्स व्हेन यू लेफ्ट फ्री दिस चार्ज, जब आप इस चार्ज को फ्री छोड़ेंगे तो क्या होगा, ये मूव करना स्टार्ट हो जाएगा, मूविंग कंडीशन में आ जाएगा. इट मीन्स इट मस्ट gain some kinetic energy. इसमें kinetic energy आ जाएगी. But according to energy conservation, energy can never be created. It means when it was at rest, जब ये रेस्ट पर था तो इसमें कुछ ना कुछ एनर्जी स्टोर्ड थी. Okay, so this stored energy is known as potential energy. Since this stored energy is in the influence of electric field, so this energy is called electrostatic potential energy. Okay, now how much energy is contained in this charge, or how much energy will possess by this charge. इस चार्ज में कितनी एनर्जी possess होगी, तो अब हमें वो कैलकुलेट करना है. इट मीन्स क्वांटिटी. Suppose this point charge is at point P and I want to move this charge from point P to point Q. अब ये point P पर है और मैं इसको point P से point Q पे ले जाना चाहता हूँ. For this I have to apply some force on this point charge towards the point P, that is known as F external force against this electrostatic force. Okay, it means on applying a force F external on this point charge, this point charge is moved from P to Q. It means a certain amount of work is done on this point charge. इस पॉइंट चार्ज को पॉइंट P से Q तक ले जाने के लिए हमें इस पर एक एक्सटर्नल फोर्स अप्लाई करना होगा और उस एक्सटर्नल फोर्स से हम इस पॉइंट चार्ज को P से Q तक ले जाएंगे. So इलेक्ट्रोस्टैटिक potential energy at point P. Suppose the electrostatic potential energy is denoted by U. So at point P, suppose the electrostatic potential energy is UP, and at point Q, the electrostatic potential energy is UQ. So the electrostatic potential energy UQ minus UP will be the work done in bringing this charge from point P to point Q. Okay, but this work done has to be done such that the acceleration of the charge should be 0. Acceleration of this charge while in moving from P to Q should be 0. Acceleration इसका 0 होना चाहिए. Why? Because whenever a work is done on a body, the body gets some kinetic energy. We had already studied in class 11 work kinetic energy theorem. वर्क काइनेटिक एनर्जी थ्योरम में हमने स्टडी किया है कि जब भी किसी बॉडी पर वर्क किया जाता है तो उसकी काइनेटिक एनर्जी में चेंज के रूप में स्टोर हो जाता है. इट मीन्स इट्स बट वी आर टॉकिंग अबाउट द पोटेंशियल एनर्जी. सो हम यहाँ पे काइनेटिक एनर्जी को इन्वॉल्व नहीं कर सकते. फॉर दिस काइनेटिक एनर्जी, चेंज इन काइनेटिक एनर्जी शुड बी 0, and it is possible only when velocity of the body is constant, and velocity is constant, it means acceleration should be 0. So the definition of electrostatic potential energy is written as the electrostatic potential energy difference between the 2 points is defined as the work done in moving the charge from a point to another point such that the acceleration of the charge is 0. Suppose point P is at infinity. अब point P को हमने कहाँ assume कर लिया? Infinity पर. So at infinity means the electrostatic force on point P is 0 because the distance is infinity and the electrostatic force is inversely proportional to r square. So जितनी ज़्यादा डिस्टेंस होगी उतना कम फोर्स होगा. तो इन्फिनिटी मैक्सिमम है तो इलेक्ट्रोस्टैटिक फोर्स 0. इट मीन्स व्हेन आई लेफ्ट फ्री दिस पॉइंट चार्ज एट इन्फिनिटी it will be at rest. It means there will be no stored energy in this charge. जब हम इसको इन्फिनिटी पर फ्री छोड़ेंगे तो इसमें कोई भी एनर्जी स्टोर नहीं होगी. इट मीन्स द इलेक्ट्रोस्टैटिक एनर्जी एट पॉइंट P is 0. So let us use this concept over here. UQ minus UP is equal to W infinity to WQ. This is 0 means UQ is equal to W infinity Q. Means this defines the electrostatic potential energy at a point, which is written as the electrostatic potential energy at a point in the electric field of some charge may be defined as the work done in bringing a positive test charge from infinity to that point. Such that its acceleration is 0. So this is the basic concept behind this unit and behind this topic, electrostatic potential energy. Let's summarize this. इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी हमें डिफाइन करना है. सपोज हमारे पास एक चार्ज कॉन्फ़िगरेशन है. इस चार्ज कॉन्फ़िगरेशन का अपना एक फील्ड होगा. इसी फील्ड में एक पॉइंट पर हमने टेस्ट चार्ज Q ले लिया. अब जब हम इस टेस्ट चार्ज Q को क्या करेंगे, फ्री छोड़ेंगे, तो ये जो पॉजिटिव चार्ज कॉन्फ़िगरेशन है ये इस पर एक इलेक्ट्रोस्टैटिक फोर्स अप्लाई करेगा, और जैसे हम इसको फ्री करेंगे तो ये मूव करना स्टार्ट कर देगा अवे फ्रॉम द टेस्ट चार्ज. तो इन मूविंग कंडीशन इट विल एक्वायर सम काइनेटिक एनर्जी. मूविंग कंडीशन में ये काइनेटिक एनर्जी एक्वायर कर लेगा, और अकॉर्डिंग टू एनर्जी कंजर्वेशन दिस काइनेटिक एनर्जी is the conversion of some stored energy at in this point charge. यानी इस पॉइंट चार्ज में कोई ना कोई एनर्जी स्टोर्ड हुई होगी जो आगे चलकर किस में कन्वर्ट हो गई, काइनेटिक एनर्जी में. इसी स्टोर्ड एनर्जी को हम क्या कहेंगे, पोटेंशियल एनर्जी. बिकॉज दिस स्टोर्ड एनर्जी इज इन द इन्फ्लुएंस ऑफ सम इलेक्ट्रोस्टैटिक फील्ड, सो दिस एनर्जी इज ऑल्सो नोन एज इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी. For the calculation of this energy, let's move this point charge from Q from a point P to Q. For this we have to do work that will be WPQ, and this work is done such that the acceleration of the charge should be 0, because from work kinetic energy theorem the change in kinetic energy should be 0, because we don't want to involve here kinetic energy. We are just talking about the potential energy. So its acceleration should be 0. And suppose if this point P is at infinity, so at infinity electrostatic force is 0. It means electrostatic potential energy at P will also be 0. At this point is taken as reference point. So using this concept over here, it means this is 0. So UQ is equal to W infinity Q. It means electrostatic potential energy at a point in the field of some charge may be defined as the work done in bringing a positive test charge from infinity to that point. This is our electrostatic potential energy. Let's define another term, that is electrostatic potential. So electrostatic potential, in our last unit electric field, we defined the electric field in terms of electric field intensity, which is also defined as the force acting per unit charge. And this electric field intensity is independent of the test charge at which electric field is going to be determined. यानी जिस पर इलेक्ट्रिक फील्ड हम कैलकुलेट कर रहे थे उससे ये इलेक्ट्रिक फील्ड इंटेंसिटी क्या है, बिल्कुल इंडिपेंडेंट. मीन्स वी डिफाइन electric field in terms of force, which is a vector quantity. The same process is here. As we had discussed in our previous topic, electrostatic potential energy. What is the work done in bringing a test charge from infinity to a particular point in the electric field of some another charge. Means यहाँ पर भी इलेक्ट्रिक फील्ड की ही बात हो रही है. तो यहाँ पे इलेक्ट्रिक फील्ड किस टर्म में डिफाइन किया जा रहा है, वर्क पे कर। सपोज इफ दिस इलेक्ट्रिक फील्ड इज स्ट्रॉन्गर देन एंड I want to move this charge from P to Q. So when this electric field is stronger, I have to do more work. जब इलेक्ट्रिक फील्ड स्ट्रॉन्गर होगा तो मुझे ज़्यादा वर्क करना होगा, और when this electric field एक weaker, I have to do less amount of work. Means मुझे क्या less amount of work करना पड़ेगा. It means we are defining electric field here as a work. हम इलेक्ट्रिक फील्ड को कैसे डिफाइन कर रहे हैं, वर्क के फॉर्म में, जो क्या है इलेक्ट्रिक आपका here we are defining electric field in terms of work. और यहाँ इलेक्ट्रिक फील्ड लास्ट यूनिट में हम इलेक्ट्रिक फील्ड किसके टर्म्स में डिफाइन कर रहे थे, इलेक्ट्रिक फील्ड इंटेंसिटी के टर्म्स, इट मींस फोर्स के टर्म्स में. तो इलेक्ट्रिक फील्ड को फोर्स के टर्म में, इट मींस वेक्टर में डिफाइन करने के लिए जो फिजिकल क्वांटिटी यूज की गई थी वो इलेक्ट्रिक फील्ड इंटेंसिटी थी. और यहाँ पर इलेक्ट्रिक फील्ड को एक स्केलर यानी वर्क के टर्म्स में डिफाइन करने के लिए जो क्वांटिटी यूज की जाएगी, फिजिकल क्वांटिटी, वो क्या है, इलेक्ट्रिक पोटेंशियल. ओके, एंड हियर द वर्क इज ए स्केलर क्वांटिटी. तो जब भी हमें इलेक्ट्रिक फील्ड को when we define electric field in terms of a vector quantity, the physical quantity used is electric field intensity. And when we want to define the electric field in terms of a scalar quantity such as work, means the physical quantity used here is electrostatic potential. Now mathematically this electrostatic potential is denoted by V. Like the electric field intensity, the electric field intensity is independent of the test charge. Here the potential is also independent of the test charge Q. So on defining this potential, we will write the work done. Suppose this point charge is moved from point P to point Q, so then the electric potential difference, between point P and Q, it will be VPQ is equal to VQ minus VP, and this will be WPQ upon per unit test charge. Means we have to make this potential independent of this point charge, because this work done or this field depends on the work done in moving this test charge from P to Q and the amount of this charge. So for generalization we have to make this potential independent of this point charge. So like in case of electric field intensity, we divide the force as by the test charge. Similarly we will divide here the work by the test charge. So this is the electric potential difference between the 2 points. So this is the, from here we can define the electrostatic potential. It means the electric potential between 2 points may be defined as the work done in bringing unit positive test charge from one point to another. तो यहाँ पे आप दो पॉइंट्स के बीच इलेक्ट्रोस्टैटिक पोटेंशियल डिफाइन कर सकते हैं. तो the electrostatic potential between the 2 points may be defined as the work done in bringing unit test positive charge from one point to another point. Okay, and if point P is at infinity, it means this work done is also written as in terms of potential energy. It means UQ minus UP upon Q. So here UP is 0, it means VP will also be 0. So we can write VQ minus VP is equal to W infinity Q. This term will go to the 0 because Vp is 0. It means Vq is equal to W infinity Q upon small. It means this defines the electrostatic potential at a point. So the electrostatic or electric potential at a point in an electric field is defined as the work done in bringing unit test positive charge from infinity to that point. So this is the electric potential at a point. Electric potential. Okay, so let's revise it. Here the term is electrostatic potential. This is also an application of electric potential or a type of electric field. In our first unit, we defined the electric field in terms of a vector quantity. It means electrostatic force. Force is the physical quantity used is electric field intensity. And here we are defining the electric field in terms of a scalar quantity. It means the work done in moving the test charge. For this, the physical quantity assigned here is electric potential or electrostatic potential. It is denoted by V and electric field intensity is denoted by E. Like electric field intensity, we made electric field independent of the test charge. Similarly, here we have to make this electric field in terms of electric field dependent only in terms of the scalar quantity. For this, we have to divide this scalar quantity work by the test charge Q. It means electric potential difference means work per unit charge. So the electric potential difference between the 2 points PQ, it means WPQ is equal to VQ minus VP. WPQ, it means work done in bringing it from P to Q, dividing by the test charge Q. Since this work done is also known as the electrostatic potential energy, जैसा last topic में हमने discuss किया. So UQ minus UP upon Q. So this gives the definition of electric potential difference. How? Electric potential difference between the 2 points may be defined as the work done in bringing unit test positive charge from one point to another. इलेक्ट्रिक फील्ड में दो पॉइंट्स के बीच में इलेक्ट्रोस्टैटिक पोटेंशियल डिफरेंस क्या डिफाइंड होगा? वर्क डन इन ब्रिंगिंग इट यूनिट टेस्ट पॉजिटिव चार्ज फ्रॉम वन पॉइंट टू अनदर. नाउ if this point is taken as infinity, then the electric energy at P is 0 and electrostatic potential at P will also be 0. Means using this concept over here, we will get VQ minus VP is W infinity Q upon Q. It means this term is 0, so VQ is equal to W infinity Q upon small q. So this gives the electric potential at a point. We can define it, the electric potential at a point in an electric field is defined as the work done in bringing unit test positive charge from infinity to that point. Clear? So These are our topics: electrostatic potential energy and electrostatic potential. Okay.